For 10.5, we're looking at the multiplication of radicals. And in order for you to multiply radicals, they have to be the same radical, and you just multiply their insides together. Like right here, the nth root of a times the nth root of b would equal the nth root of a times b. So let's try this out. On number 1, you want to just say the square root of 5 times 7 to get the square root of 35. Now, 35, we could try to reduce that radical, but that radical does not reduce. So the square root of 35 in this case is our answer. Looking at number 2, all we have to do is say the square root of 6 times 10, which gives us the square root of 60. That almost makes too much sense, doesn't it? Now, what we have to do from here, we want to make sure that our radical is completely simplified. I'm going to list all the prime factors of 60. 60 is 2 times 30. 30 is 2 times 15. 15 is 3 times 5. So there's that group of 2 that can come out. So I will call this 2 square roots of 15. On number 3, when we're given the square root of b times the square root of b, you would just write your square root back down and say b times b. B times b is b squared. And the square root of b squared, the square root undoes the square to just leave you with b. On number 4, you have 3x square roots of 5 times x square roots of 10. So essentially what you're doing is you're saying 3x times x and the square root of 5 times the square root of 10. There's really no need to write it out like that because I've really made it look a little bit more complicated. But what this ends up being is just 3x squared square roots of 50, because 5 times 10 is 50. And then we want to look at 50 to see if we can write the prime factors to possibly reduce that radical. 2 times 25, 25 is 5 times 5. So we can bring a 5 out front to call this 15x squared square roots of 2. Now on number 5, we have a bit of an application problem. We're looking at finding the exact area of a triangle. The area of a triangle formula is 1/2 times the base times the height. So in this case, we will have 1/2 times, let's see, the base is the square root of 6, the height is the square root of 54. So we'll just say 6 times 54 is the square root of 324. So at this point, you just want to look and see if that radical of the square root of 324 reduces. And you could write out all the prime factors, but it is always, maybe a good idea to type in the calculator as well to see if it's a perfect square. And the square root of 324, if we type it in the calculator, it does not give us a decimal. It gives us a pretty 18. So 1/2 times 18 is 9 centimeters squared for our area. So let's try some that have some variables, and we're going to assume that these variables represent positive real numbers. And so on number 6, you have a square root for both of them, and 5 times 5 is 25, y times y is y squared. Well, that's the square root of 25 times the square root of y squared as well. The square root, and you don't have to rewrite it like that, but just know the square root of 25 is 5. The square root of y squared is y, and there's no need to write the absolute value bars with that because we're assuming that these variables are positive real numbers. So let's try another. On number 7, You have 6 times negative 7, which is negative 42. And inside that radical, you're saying 7x times 5. And the square root of 35x, that radical does not simplify. So negative 42 square roots of 35x is our final answer in that case. Now on number 8, these start getting a little bit more interesting. Let's just pretend that let's make up a problem really quickly. Let's say we had 2x and we needed to multiply that by x minus 4. Well, that would be 2x times x is 2x squared, and 2x times 4 is negative 8x. Well, that's essentially what we're doing right here. We need to distribute the 2 square root of 3 and to the square root of 6 and to 4 square roots of 5. So that will give us 2 times the square root of 3 times 6 minus 2 times 4 is 8, the square root of 3 times 5. I will say 6 is 3 times 2, so that would give us a group of 2, so I can bring a 3 out with the 2 that's in the front to give me 6 square roots of 2 minus 8 square roots of 15, and they don't reduce any from there. Of course, again, I did do the reduction right here. I rewrote 6 as 3 times 2. So this would be our final answer. Working another. Instead of this being just, you're distributing one thing, we're actually foiling it this time. So compare it to like x plus 5 times x plus 2, where you say x times x and x times 2 and 5 times x and 5 times 2. We're going to do the same thing. So the square root of 6 times 4 square roots of 6 would be 4 square roots of 6 times 6 plus the square root of 6 times the negative square root of 10. And I said plus. It's actually going to be a minus. 6 times 10 is 60. Now I'll say 2 square roots of 10 times 4 square roots of 6 to give me 8 square roots of 60. And 2 square roots of 10 times the negative square root of 10 would give me negative 2 square roots of 100. Cleaning this up just a bit, 4 square roots of 36 minus the square root of 60 plus 8 square roots of 60 minus 2 square roots of 100. The square root of 36 is 6, so I'm going to say 4 times 6 is 24 minus the square root of 60. 60 is 2 times 30, which is 2 times 15, which is 3 times 5. So 60 can be rewritten as 2 square roots of 15. So let's just kind of rewrite the problem. 24 minus 2 square roots of 15 plus, now we have a square root of 60 right here, so that's going to be 8 times 2 square roots of 15 minus, okay, the square root of 100 is 10. So 2 times 10 is 20. Like terms, I have 24 minus 20, which is just 4. And then I can say negative 2 and 8. Well, 8 times 2, that's going to be 16. Negative 2 and 16 have like radicals of the square root of 15. So we're just going to call that 14 square roots of 15. And on number 10, we're distributing the 2 term to 3 terms. So a times 3a is 3a squared. A times 2 square roots of a is 2a square roots of a. A times negative 2 is negative 2a. Now for our 3 square roots of a, I'm going to distribute to 3a, which will give me positive 9a square roots of a. Let me make sure my 9 doesn't look too much like an a. Okay, now 3 square roots of a times 2 square roots of a is 6 square roots of a times a, which is a squared. And then 3 square roots of a times negative 2 is negative 6 square roots of a. So as far as simplification goes, this one is a little different. I am going to almost rewrite the whole thing and reduce any radicals that I can. And the only one that I can reduce is the square root of a. Squared is a, so this becomes 6a. And then we just have the minus 6 square roots of a right here. So we have, as far as the square roots of a go, we have, let's see if I can highlight it. We got 2a square roots of a, 9a square roots of a, and negative 6 square roots of a. So let's write that out like this. Okay, and then we would have plus the 3a squared in the front, and then we have negative 2a and positive 6a. So 2a plus 9a is 11a minus 6 square roots of a plus 3a squared plus 4a. And I'm just going to distribute this square root of a that's right here back out to the 11a and the 6 to give us 11a square roots of a minus 6 square roots of a plus 3a squared plus 4a. Go ahead while we're on this page and look at this definition, expressions of the form the nth root of n, the nth root of a to the n power. If you have an nth root of a to the n power, and it's a real number, then the nth root of a to the n power, the nth root and the n power undo each other, and you are just left with a. So let's apply that principle on this next page. Okay, if we're thinking about what we just looked at, then the cubed root undoes the cubed for an answer of just 7. And the fourth root undoes the fourth power for an answer of AB. And the squared really is going to the 3 and the square root of m, kind of like this. So this one would actually be 9m. So the square, the power of 2, still undid the square root, but I also had to give the power of 2 to the 3. So let's recall these two formulas for special case products. If you have an A term added to a B term and it's squared, then when you multiply it out, I mean, you could FOIL A plus B times A plus B. You could FOIL that out. But once you FOIL it out and combine your like terms, you will end up with A squared plus 2AB plus B squared. And if you FOIL out A minus B and A minus B, so A minus B squared, you would get A squared minus 2AB plus B squared. Pretty much the same thing, except that the 2AB, if it's A plus B, it'll be positive. If it's A minus B, it'll be negative. So if we're looking at number 14, that's going to apply to the A minus B squared. So it will be an A squared minus 2AB plus B squared. And our A is the square root of R, and our B is 3. So we're going to do the square root of R squared minus 2 times the square root of R, because that's A, and B is 3, and on the end we got 3 squared. So we end up getting the square root of R squared is R, because the square undoes the square root, minus 6 square roots of R plus 9. And let's try that on 15, except it's the special rule at the top. So we will be referring to A squared plus 2AB plus B squared. And our A is 6, and our A is the square root of 6, our B is the square root of 7. So we have the square root of 6 squared, and we have 2 times the square root of 6 times the square root of 7 plus the square root of 7 squared. So the square root and the square undo each other. Right here, 6 and 7 get multiplied by each other. And again, the square root and the square undo each other, so we just have 7. The only thing I want to look at is that square root of 42. 42 is 6 times 7, but 6 is 2 times 3. Well, that does not reduce like I thought it might. So we'll just leave that as 2 square roots of 42, and we're going to add 6 and 7 together to get 13. For the ones at the bottom of the page, we're going to recall the difference of squares formula, to where you have these two conjugate binomials, and when you multiply them, you notice the A and the A are going to be A squared, the B and the B are going to be B squared, and you put a minus sign. And this only happens when they're the same A and B, but have different signs in the middle. So this is the case. They're the same A and B, but the middle has different signs. So it will equal A squared minus B squared. That's what it's going to equal. And our A was the square root of 3, our B was 7. So the square root of 3 squared minus 7 squared. Well, that's just 3 minus 49, which is negative 46. And in this case, our A is the square root of S, our B is the square root of T. So the square root of S squared minus the square root of T squared, which will just give us S minus T. So on this next page, we're starting off with a continuation of our difference of squares formula. You notice that our A's and our B's are the same, but we have different signs in the middle. Actually, for both of these problems, okay? So I'll go ahead and point that out. So our a is 5 square roots of y, and you square that because we're doing a squared minus b squared minus b squared. So b was 4 square roots of z, and you square that. So we get 25, and the square root of y squared is just y, and 4, the square root of, excuse me, not 4, you have to square the 4. So 16, and the square root of z squared is just z. Now on 19, you have a of 2 square roots of 5, so you square that, and you subtract the square root of 3 squared. 2 squared is 4, the square root of 5 squared is 5, and the square root of 3 squared is 3. So 20 minus 3, which is 17. And to finish out the rest of the page, it just looks like we have some good practice. On 20 part A, I have to distribute the 2. So 2 times x is 2x, and 2 times 5 is 10. But let's compare that to the square root of 2 times the square root of x plus the square root of 5. So I still distribute, and it's the square root of 2 times x, so 2x, and the square root of 2 times 5, so the square root of 10. You do want to look to see if those radicals simplify. They do not. Look, this is another, on 21 part A, this is another difference of squares formula. So we're going to take your a term of 2x and square it. We're going to take your b term of 7 and square it, put that minus sign in between them. That becomes 4x squared minus 49. But let's compare that problem to another difference of squares that looks kind of similar, except this is 2 square roots of x and 7 as your a and b. So this time you have 2 square roots of x squared minus 7 squared still, and 2 squared is 4. The square root of x squared is x minus 7 squared is 49. Okay, and then for the last two, again, remember this formula will be a squared minus 2ab plus b squared. So a is a and b is 9. So a squared minus 2 times a times 9 plus b squared, so 9 squared. We end up getting a squared minus 18a plus 81. And let's compare that to x minus 2, the square root of x minus 2 minus 9 squared. So it's that same formula. A is the square root of x minus 2, b is 9. So a being the square root of x minus 2 squared minus 2 times a, so square root of x minus 2 times 9 plus b squared, so 9 squared. The square root of x minus 2 squared is just x minus 2. We're not going to put absolute value bars around it because it did tell us to assume that the variable is represented positive real numbers. And so now we're going to go ahead and multiply out the negative 2, the square root of x minus 2, and 9 to get negative 18 square roots of x minus 2. And on the end, we have plus 81. So I end up saying 81 minus 2 is 79 minus 18 square roots of x minus 2.